Hi, I'm Herb Gross, and welcome once again to our Math as a Second Language workshop video series where we'll be talking about adding and subtracting decimals today. This is a topic that students don't usually have much trouble with. But again, many times what they do is by sheer rote, and they have no real feeling as to what the final answer means. What I want to show is that using the adjective noun thing makes the rote recipe easier to internalize so that you start to be able to use it not just mechanically, but to be able to visualize what's really happening. Let me take as a case in point a problem such as this. You're asked to add 28.3 and 7.93. By the way, I'll keep saying 28.3 and 7.93 for brevity. I hope you'll emphasize to your students to read these numbers as 28 and 3/10, 7 and 93 hundredths. Because, again, by putting in the word point, as I mentioned before, 17 is greater than 5, so students will think that 0.17 is greater than 0.5, not realizing that 0.17 is 17 of what it takes 100 of. 0.5 is only 5, but 5 of what it takes 10 of, okay? Now, getting back to this, what were you told to do mechanically? You were told to line up the decimal points. In other words, write these vertically, line up the decimal points, and then add as if the decimal points weren't there. By the way, it's kind of interesting. There's nothing over here. If you like balance, just put the 0 in here. See, that 0 doesn't change anything. The only time 0 changes something is if you insert it before the final digit, the final non-zero digit. For example, if I were to put the 0 over here, this is still 3. But now the 3 is in the hundredths place, not in the tenths place where it's supposed to be. On the other hand, if I put the 0 here, that didn't move the 3 at all, and so this is still 3/10 whether the 0 is here or not. Anyway, let's read this now verbally. 28.3, if you didn't see the decimal point, would be 283. But what's the noun? What's the unit? Since there's one digit to the right of the decimal point, it means that the unit is tenths. In other words, the number of zeros corresponds to the number of digits over here. 7.93, without the decimal point, is 793. But since there are two digits to the right of the decimal point, the 793 is modifying hundredths. So now, you're adding 283 and 793. Are they modifying the same noun here? No, remember what we said. 283 plus 793, we don't even add them unless they're modifying the same noun. Somehow or other, we have to get these nouns the same. Now, here's where the 0 becomes important. To make the nouns the same when you're dealing with decimals, the number of digits to the right of the decimal point has to be the same in both numbers. So here's the case where I would put in this 0, and what I would say is what? Another name for 283 tenths is 2,830 hundredths. So now the problem becomes 2,830 hundredths plus 793 hundredths. Because the two adjectives are modifying the same noun, now we can add them, exactly like we did over here. And we keep the common noun, which is hundredths. And what's the price that we pay if we don't want to use the word? To leave out the word hundredths, since it represents two digits to the right of the decimal point, we can cross this out, put the decimal point over here, and now we have the validation to what we were doing mechanically before. In other words, nothing has changed other than now you can see the logic of why we had to line the decimal points up. Okay, let me tell you why I think this is important. For a beginning student who's just doing things by rote, it's very easy for them to confuse one thing where it's correct to do something with another thing that's similar but not correct to do. Suppose, for example, the student was given the problem 283 plus 793, no decimal points. They would line the numbers up vertically and they would add them, okay? Very, very common. Now, let's take these same two numbers, but put the decimal point in so we now have the problem that we were just working on. The student locked into this can very easily say, I want to keep this structure. So they copy it exactly the same way so that the 3 here and the 3 here line up. And they have no idea what to do with the decimal point, but they know that 3 plus 3 is 6. The trouble is 3 plus 3 is 6 only when the two 3's are modifying the same noun. If you look at this 3 is the first digit to the right of the decimal point, so it's modifying tenths. This 3 is in the second column to the right of the decimal point. It's modifying hundredths. If I want to add the 3/10 to anything, what do I have to add it to? I have to add it to something that's modifying tenths. So what I would have to do is shift over and add the 3 and the 9, and notice that doing the problem correctly lines up by lining up the decimal points, you've automatically done that. Now, the other thing I want to point out is, if you're in doubt, you can still get an estimate to the right answer by having a number sense. Look, 28.3 is more than 28 but less than 29. And 7.93 is more than 7 but less than 8. So whatever this sum is, it has to be more than 28 plus 7 but less than 29 plus 8. 28 plus 7 is 35. 29 plus 8 is 37. So whatever the correct answer is, it has to be in between these two numbers. There are several numbers in between 35 and 37, but there are an awful lot that aren't. So it gives you a very quick check. What I'd like to do next is to show you again the problem with not understanding the adjective-noun theme. Let's suppose, by review, let's just look at 28.3 plus 7.93. We didn't bother putting the 0 in over here, and the student who's memorizing says, oh, we just bring the 3 down because there's nothing over here. And when they do this, they get the correct answer. Now, the reason they got the correct answer is that even though nothing was written here, it was assumed to be a 0. And 3 plus 0 happens to be 3, so there's no problem if you eliminate or forget to put in the 0. But let's suppose we were subtracting instead, and the student still had this gut feeling that since there was nothing over here, I just bring this down. They would bring down the 3 and then subtract in the usual way. They would take 9 from 13, etc. We don't have to go through the steps. And you would arrive at 20.43 as the answer. Now, I don't have to argue with a student to say that's the wrong way. That's one of the worst ways of teaching. If you say that's wrong, all the student has to say, no, it's just a different answer. See, you have to, when something isn't working right, you have to be able to show the students on their terms why it's not right. Now, what was the definition of subtraction? It's the number you have to add to this number to get this number. If this were the right answer, what should happen? If I take 20.43 and add 7.93 to it, the answer should be 28.3. If I do this, look what happens. 3 plus 3 is 6. 4 plus 9 is 13. Put down the 3, carry the 1. 7 plus 1 is 8. This comes out to 28.36, which is close, but it's wrong. In other words, this is not the right answer. On the other hand, suppose we put the 0 in. Now when you subtract, you say, I can't. See, here's the difference. When you add 0 to 3, nothing changes. But when you're subtracting 3 from 0, that's completely different. There has to be something over here. In other words, 0 minus 3 is not 3 anymore. So at any rate, now what you do is you subtract the correct way. You put the 0 in here, you subtract, you get 20.37. How do we know that's the right answer? Well, we're going to check it. If this is the right answer, if I take 20.37 and add it to 7.93, I should get 28.30. And sure enough, that's exactly what happens. Here's a good rule of thumb. When you're not sure whether to put the 0 in or whether to leave it out, put it in. Because if you didn't need it, nothing bad will happen. But if you needed it and you left it out, then something bad can happen. So again, don't memorize, but whenever you're in doubt, say, look, it won't hurt if I do this. Okay? There's a very nice logic to that. Don't worry if something you do can't cause any harm. Okay? By the way, if you still have trouble, suppose you've never heard of the adjective noun thing, and you still wanted to check whether you were doing things correctly with decimals, notice that the adjective noun theme doesn't prevent you from doing anything else you wanted to do. For example, given a problem like 28.3 minus 7.93, if you're comfortable with improper fractions, look what happens here. Without the decimal point, this would be 283. That gives you the numerator. Since there's one digit to the right of the decimal point, the denominator is going to be a 1 followed by 1 0. Over here, without the decimal point, you would have 793. That becomes your numerator. Since there are two digits to the right of the decimal point, your denominator becomes 100. You put in 2 zeros here. Now you can't subtract these. We don't have to say because the nouns aren't the same, but you don't have a common denominator. Well, this is hundredths, this is tenths. If this was hundredths, I'd be all right. How do I make this hundredths? Well, I can multiply the bottom number by 10 and the top number by 10. Now I'm okay. Now I can subtract in the usual way. My numerator becomes 2037. My denominator is 100. What does the denominator tell me? If I want to write this as a decimal, the 2 zeros tell me I have to have two digits to the right of the decimal point. So that means I'm going to write the answer this way, which again corresponds to the answer we were supposed to get. So again, notice that I haven't taught you anything new other than to show how the adjective noun theme, remember that's our main theme, unifies all of the topics in the arithmetic curriculum. Okay? Well, since this is so similar to whole number arithmetic, I thought that what we would do for our practice problem today is to talk about something that we haven't talked about, but to show that it works exactly as it did for whole numbers. And so I thought our practice problem today would simply be an exercise in rounding off. Here's the problem. By rounding off each number to the nearest tenth, estimate the sum. I'm not going to read all these digits off to you, but I think you can see it's kind of a mess. What happens is, a lot of times in today's technology, we measure to a great degree of accuracy. Now, to do this problem longhand is quite tedious. Nowadays, with a calculator, the problem is not that bad. But in the old days, what would happen is we would round off. In other words, we might round off to the nearest whole number, we might round off to the nearest hundredth. The point is it would be exactly the same way as we would do it if we were dealing with whole numbers. The only difference is we're using fractional denominations rather than whole number denominations. So at any rate, pause the video, look at this problem, solve it, then come back and we'll discuss the solution, okay? Okay, now the problem told us to round off each of these numbers to the nearest tenth. So what we do is, the same way as we would have done with whole numbers, we look for the denomination that we're going to round off to. In this case, it's tenths. And what we're going to do is leave this digit alone if the digit that follows it is less than 5, and we'll increase it by 1 if the digit that follows it is 5 or more. So the 24.3 blah, 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 because the digit after the 3 is a 9, becomes 24.4. The 8.08, the digit that follows the 0 is an 8, so this becomes 8.1. In a similar way, this becomes 37.8. We don't have to worry because the digit to the right of the 8 is less than 5, so it becomes 37.8. This becomes 18.4 because the digit to the right of the 4 is less than 5. And this number here, 9.399, the digit here is a 3, the digit to the right of it is a 9, and what that tells us is that we're going to make the 3 into a 4, and now what we're going to do is add up these numbers. which again, I won't bother doing. I think you can do that. This may still look tedious, but it's a lot less tedious than having to do this. And again, let me point out that if you're in doubt, you can get a check. For example, we know that whatever this number is, it's more than 24. This number is more than 8. This number is more than 37. This number is more than 18. And this number is more than 9. If I add these up, 12, 19, 27, 36, put down the 6 and carry the 3. 3 and 2 are 5. 3 more is 8, and 1 is 9. That tells me that the correct answer has to be more than 96. What does it have to be less than? Well, this number is between 24 and 25. Let me see if I have a different color here. So 25 would be too big. This number is less than 9. This number is less than 38. This number is less than 19. This number is less than 10. So I can add these up. By the way, a shortcut for adding these up isn't each of these numbers one more than the corresponding number here? So in other words, since I'm adding up 5 of these numbers, the answer should be 5 more than what it is over here. We can check that if you want. But what that tells me is that even before I start this problem, or even after I've done it, if I want to make an even quicker check, I know that the right answer has to be between what? 96 and 101. Okay? Anyway, guys, I think this is a fine place to stop for today. I will look forward to seeing you next time when we're going to talk about multiplying decimals. And again, you're going to see the power of the adjective noun theme here. But until next time, have fun, be well, see you soon.